In lieu of having class today, since I'm not feeling well, I'm going to go ahead and do what's called a video lecture. It's kind of interesting, but it's a different way, and I hope everybody can access it. We're going to begin talking about linear functions, and yes, we're talking about algebra, but algebra is just a tool. Okay, and you may go, oh my gosh, someone's mixing my letters with my numbers, and I've got a big bowl of alphabet soup. But what we'll see is that we only use letters to represent numbers we do not know. They're called variables, and they're shorter than writing out what the quantity represents, so we'll see that as we go. But first of all, we will begin talking about linear functions. And what is a function? Okay. A function is a relationship where you have an x value and a y value, okay, or a first value and a second value, and no first value gets paired with more than one second value. Okay, so an example would be like if I asked three people what color their cars were. So I asked Bill, I asked Ted, sorry about that, and then I asked Fred. Okay, and Bill said he had a red car, and Ted said he had a blue car, and Fred said he had a white car. Now, this would be an example of a function because each of these first values only got paired with one second value. Now, suppose we change this a little bit, and Bill ended up having a red car and a white car. Okay, so now our pairs would be Bill goes with red and Bill goes with white. Well, our first value cannot go to more than one second value, so this would be not a function. Okay, and then of course if I took away Bill's little line here going to white car, then we would have a function. Now when we're comparing numbers, if we have some sort of relationship between two numbers where we have a constant increase all the way, every time we add something or do something for a few more minutes or whatever, and we have a constant increase, that's when we get a linear function. That's what makes it linear. And we'll see some examples here. And this rate is what we call the slope. And again, we'll talk about how to find slope and what to do with slope. But first we're going to look at one of the problems from the book. Okay. So on page 292 we have this problem. The foundation for a brick wall rises 10 inches above ground level. The bricks used for the wall are 8 inches high. First we want to find a function that determines the height of the wall in inches based on the number of layers of brick that have been laid. Then we want to sketch the graph, and then we want to find the equation that would give you the height of the wall in feet. So we have a little sketch here. Okay, and again, this was 10 inches for our foundation, and then every layer of brick is 8 inches. Okay, so our first layer would give us 8 inches, then our second layer would give us 8 inches. Now, we've got to write a function. Well, we don't have to sit down and write out a formula first. And this may be easy for you to look at and write a formula for, but let's just look at some values and then we'll worry about writing a function. Okay? So let's look at the if we have different amounts of layers of bricks, what the height of the wall would be. Okay, so suppose we have 0 layers. We have just got the base. Well, then all this top part would be gone here, and the height would be 10 inches. I add a layer on, and now I have 10 inches and 8 inches is 18 inches. Add another layer on, whoops, so this should be first layer. Second layer, we add another 8 inches on, so 18 and 8 more would be 26. Add another layer on, and we get 26 and 8 more, which would be 34. And we keep on with the same process. Okay, we don't ever add the 10 inches back in, it stays there. So then what we have is we have 8 more than 34, which is going to be 42. Okay, and we continue the same process. Okay, so what we have here is we start out with 10 inches, okay, and 0 layers of bricks, 10 inches plus 1 layer of bricks, okay, which would be 8 inches, so 1 layer at 8 inches. For the second layer of bricks, we'll have 10 inches plus 2 layers at 8 inches. Third layer will have 10 inches plus 3 layers at 8 inches, and so forth. Now, suppose I want to translate this pattern into words, okay? Well, and this is all equal the height for 1 layer, for 2 layers, and so forth. So the height of the wall is going to be 10 inches plus so many layers at 8 inches each. Now, again, if I were to write this out with words, and I would put number of layers and the height of the building at so many layers equals, I'm going to have this big long sentence. But instead, I'm going to use some symbols. The height of the wall is 10 plus number of layers. Well, I don't know what that is, but I'm going to call it n, whatever that happens to be. At, so we're going to multiply it, times 8. And usually, you see the 8 written before the n, the number first. And if we put it like this, or we put our variable term first, we have an equation. We just wrote the equation for the height of that wall.